Good morning, JR2. Okay, now we're going to take lesson number 4. I want you all to know that water is very, very important in communities. The water is very, very important for our planet and in the communities. Okay? Do you know what does our planet called? It's called the Earth. So what does our planet called? It's called the Earth. Can you tell me in what form we can find water in the Earth? We can find liquid, gas, and solid. We can find again liquid, gas, and solid. Our planet, the Earth, is mostly covered with water. So the most of our planet is covered with water. Now I want you to open page 155. Planet Earth from space. This is a picture of our planet, the Earth, taken from a satellite. Do you remember what satellite means? We said before that satellite is a camera. It's in the space. It can take pictures for stars and galaxies, and it also can take pictures for the Earth or our planet. Okay? So this is a satellite picture for our planet, the Earth. Okay? We can find in this picture we can find land. Okay? The land are the yellow and brown parts. We can find water. The water is the blue parts. We can find clouds. Clouds are the white parts, and down there at the bottom we can find ice. Okay, so there is the water, it's a liquid form, clouds as a gas form, and ice as a solid. And as you can see, I pointed to the location of our city, which is our country, which is Egypt. Okay, this is Egypt. Okay, as I said before, most of our planet is covered with water. Okay, this picture that you can see is not the whole of the Earth, it's only half of it. This picture is only half of the Earth. We can't see the other side of the Earth. So this is only half of the Earth, not all of it. Okay? There is also an ice or a solid form of the water in form of glaciers. Glaciers are rivers from ice or frozen rivers. Okay? So as I said before, we can find all three forms of water: liquid as water, gas as clouds, and solid as glaciers or ice. Okay, now turn the page. Open page 156. Okay, let's read. Look at the picture, read the text, circle and label the three forms of water using different colored crayons. Okay, at the top, the white color is gas form as clouds, and this huge white mountain is a solid or ice mountain, and down there is the liquid form, which is water. Let's read. This picture was taken in a very cold place on Earth. An iceberg is a very large piece of ice floating in the ocean. So this mountain, this white mountain, is called iceberg. It's called what? Iceberg. And iceberg is a very large piece of ice floating in the ocean. Icebergs are often as tall as a 6 to 10-story building. So these icebergs are too high. The tallest iceberg on record rose nearly 55 stories above the water. So the tallest iceberg is called Rose, and it's nearly about 55 stories above the water. Large icebergs are also called ice mountains. So iceberg also called ice mountains. So again, water can be seen in all three forms in this picture: solid, liquid, and gas. Okay, JR2, can you tell me, does all the liquid water on earth are the same? No, of course not. There are two types of water. There are salty water and fresh water. Salty water, as we can find it in oceans and seas. And this, or the properties of the salty water is wet. It's wet, cold, it's very cold, and it's very deep, and its color is blue, and it's salty. Okay, but can we drink the salty water or the water of the ocean? Of course not, we can't drink it. The other type is fresh water. We can find fresh water in the lakes, rivers, or underground springs. Underground springs, when people dig very deep in the earth, they can find water down there. Okay? This fresh water, we can drink it. As we are in Egypt, we drink the water of the Nile River. Okay? We can do both in fresh water and salty water. We can go swimming, we can fishing, and we can boating. Okay? But we can drink fresh water, we can watering. Okay, we can watering crops from fresh water, but we can't water the crops from salt water. So again, there are two types of water: salty water and fresh water. Salty water, we can find it in oceans and rivers and seas, and it's wet, cold, deep, blue, and salty. We can't drink the salty water, and we can't water the crops. Fresh water, we can find it in lakes, rivers, and underground springs. We can drink fresh water. We can water crops from fresh water. We can go swimming, fishing, and boating in both water, fresh and salty. Now turn the page and bring page 157. Look at the pictures, read the text, answer the questions. This is a map of Egypt. Point to where we live. We live up there in Alexandria. The blue curvy line running through the country is the Nile River. What festival do we celebrate each year that involves the Nile River? We took before that each year we celebrate Wafa al-Nil. The festival is Wafa al-Nil. And we said that Wafa al-Nil, we celebrated to celebrate the flooding of the Nile. So Wafa al-Nil, we celebrate the flooding of the Nile. Okay, we took it before, and we said that before, ancient people, when they saw the Sirius star rising just before the sun, it means that the Nile will float. And because we built the Aswan High Dam, there is no flooding, or there are no more flooding now. But we make a festival for this called Wafa al-Nil. Okay? The boat is sailing on the Nile River. The Nile River is fresh water. How do we use the fresh water in the Nile River? We use the fresh water of the Nile River in drinking, cooking, bathing, watering crops, and fishing. So again, we can use the fresh water of the Nile River in drinking, cooking, bathing, watering crops, swimming, and also fishing. Okay? The last question is, where does fresh water come from? Fresh water comes from rivers, lakes, underground springs, and rain. Again, fresh water comes from rivers, lakes, underground springs, and rain. Now, JR2, I wonder, can we reverse the changes of water? For example, if we put liquid water in the freezer to make ice, can we make liquid water from ice? Yes, for water we can freeze liquid water to make ice, and then we can warm the ice to make liquid again. Can you think, or do you think we can always reverse a change in form from temperature? No. So not all the things can be changed. Okay, now I want you to turn the page and bring page 158. Now, if we cracked open a raw egg means that it's not cooked. It's not cooked yet. If we cracked open a raw egg, what can we see? We can see that the egg is liquid. The egg is liquid. Now we are going to compare what happens to the egg with what we know about the water. Okay? What has to happen to liquid water to make ice? What should we do? We should lower the temperature or decrease the temperature. Okay? And this process called freezing. So again, what has to happen to liquid water to make ice? We should lower the temperature or decrease the temperature, and this process called freezing. But what has to happen to the liquid raw egg before it becomes a solid egg? We should raise the temperature or increase the temperature. So again, if you want to make or if you want to cook the raw egg, we should raise the temperature or increase the temperature. So now, what are the difference between making liquid water into solid ice and making a liquid raw egg into a solid egg? To make the liquid water into solid ice, we should lower the temperature. And to make the liquid raw egg into solid egg, we should raise the temperature. Okay? So there is only one requires a temperature decrease one requires a temperature decreases and one requires a temperature increase. Again, one requires a temperature decrease and one requires a temperature increase. So both of them require a temperature change. Again, both of them require a temperature change. Okay? Okay, now what has to happen to solid ice before it becomes liquid water? Again, what has to happen to solid ice before it becomes a liquid water? I should raise the temperature or increase the temperature. Again, I should raise the temperature or increase the temperature. And this process called melting. Okay. Can we reverse the change that happened to the cooked egg and make it back again as a raw egg? No. The answer is no. We can't change or reverse the change that happened to the cooked egg and make it again become a raw egg. And that's why, because when we cook an egg, the heating causes a change in the material that can't be reversed. Again, when we cook an egg, the heating causes a change in the material that can't be reversed. And this is true for many items that are cooked. Okay? So again, we can't reverse the change. Why? Because when we cook an egg, the heating causes a change in the material that can't be reversed. So, heating and cooling sometimes can change the properties of the material and create something totally new. Again, sometimes heating and cooling can change the properties of the material that or create something totally new. Okay? Sometimes also when we mix two different materials, it creates something new. Like what happened to when we inflate the balloon. Do you remember when we put baking soda on vinegar and we mix it together? What happened? They create a gas that inflate the balloon. Okay? And sometimes the change are reversible and sometimes they are not. Again, sometimes the changes are reversible and sometimes they are not. Okay? If I have an ice cream cone and it melts in a very hot day, can we reverse this change? Can we make it freeze again? Yes. If I put the liquid ice cream in the freezer, it can be changed to a solid again. Okay? Now let's read page 158. Use the images to complete the first two descriptions, then answer the questions below. Describe the inside of a raw egg. The raw egg is liquid. Now describe a cooked egg. The cooked egg is solid. So the cooked egg is solid. Okay. What made the egg change? Increasing in the heat, on the temperature, sorry. Okay, so what made the egg change? Increasing the temperature. Can you reverse the change to make a cooked egg raw again? No, we can't reverse. Okay, so we can't reverse the change and make the cooked egg in raw again. Okay. Now we have been learning about properties of materials and how materials can change. This will help us build a monument. What is the monument? A monument is a model for honoring someone or something important. Again, what is the monument? Monument is a model for honoring someone or something important. For example, the pyramids. The pyramids of Giza, the three pyramids, are a monument. There is also a statue for someone important, like Saad Zaghloul. So those are monuments, okay? We need to consider the properties of materials before we use them to build things. So we should know the properties of the materials that we are going to use to build any monuments, okay? Because the monuments are built outdoors, we can find the monuments in the streets. So we also need to know how the weather will affect them over time. So we should know how the weather will affect the monuments over the time, okay? We have been learning about how heat can melt ice. Do you know or think with me, can the heat from the sun melt rocks? Of course not. The heat of the sun can't melt rocks, okay? So when we build a monument, we should choose a materials that can withstand the heat from the sun. So when we build a monument, we should choose materials that can withstand the heat from the sun. For example, if I build a monument from the ice in Egypt here, will it stand? Of course not, it will melt. The ice can't stand the heat of the sun. So when we build a monument, we should choose materials can withstand the heat from the sun. Okay? So now we know that the sun is a factor in choosing materials to build monuments. Again, now we know that the heat from the sun is a factor in choosing materials to build monuments. There are also another things that affect the building. Okay, there are also another thing that can affect on a monuments. Okay, like what? Like wind, like rain, like if the weather is cold or hot. Okay, now I want you to open page 159. Look at the pictures, describe what you see in the pictures that might affect a monument that is built outside. The first picture we can see sun and heat. The second picture we can see wind. And the last picture we can see rain and cold. So again, when we build a monument, we should consider the weather or something like the heat of the sun, the wind, and the rain, or if the weather is cold. Thank you, Junior 2. I hope you enjoy these lessons. Bye.